Great. Now we are the last part, right? The last special case. That's where the velocities are inclined at any other angle aside being parallel or aside being at 90 degrees. Yes. So generally, there is this formula that we have been using all this while, right? If you have two velocities, two bodies A and B moving with their velocities, we say that velocity of A relative to B is equal to VA minus VB. This has been the how do you call it? The mathematical representation of relative velocity all this while we're using all the cases already, and the same thing applies here. But then we are going to use a special approach in this case, right? A special approach when the velocity are given and the angles are given they are not 90 degrees. The special case, even it's not even a special case, that's the general case for all of them, right? The general case is, I call it magnitude and bearing form. Magnitude, magnitude bearing form. Bearing form. This is the general case for adding and subtracting vectors together, giving their angles and all that. It will apply everywhere. So we are going to convert them. These are vectors, right? They are going to vectors are supposed to be having arrows on the top. So mathematically, when we represent them, the arrows are just telling them these things that we are manipulating are all vectors. So, but first we need to convert them to vectors, each of them to vectors, and then the rest of the thing becomes simplified from there. So we are going to use the general method for these particular cases where the angles are not 90 degrees or parallel, right? So we are going to see how to do this and learn alongside, right? So what we do now, velocity of VAB, right? Vector form is equal to velocity of A, right? Let's say A has a magnitude. A has a magnitude. We actually write it as the magnitude. Let's say small a, comma, and the angle. The angle, let me say theta A, and the B has a magnitude small b, and then an angle of theta b. The general formula for the relative velocity is, so you should make sure that the theta, right? Theta are bearings. You should make sure that these guys are in bearing form. We learned this in previous sessions, so kindly revisit that to do how to find bearings. We took our time to explain those ones so that you can understand. So we should convert the theta to bearing form in their bearing form. So we have magnitude and bearing form. Then you have for A, right? VA is going to be A sine theta A, and then the bottom you have A cos theta A minus, then VB is going to be small b sine theta B, small b cos theta B, right? Then when you are doing the subtraction, right, you do this one minus this one, then you do this one minus this one, then you get the final answer, which will also in vector form. When this is vector form, we now have to convert it back to magnitude and direction, and then you just state the answer as so. Don't worry. We are coming to solve a lot of some of the questions so that you understand. But let's know that we are going to use the approach of magnitude and bearing form to quickly solve this. Now let's look at the first example. Let's say a car is moving at 80 kilometers per hour in a northeast direction. Let me represent that. So car a car is moving. Let's say velocity of the car, C is for car, right, is 80 kilometers per hour in northeast direction. Northeast direction. Let if you have the cardinal point, this is north, this is east, this is west, and this is south, right? Northeast direction. If you say northeast direction, meaning exactly in the middle of north and east, exactly in the middle of north and east, right? And you know that the whole of north and east is 90 degrees. Half of it is 45. So here you have 45 degrees, and from north to here to have 45 degrees, right? So northeast, and then a wind is blowing from the north at 20 kilometers per hour. So velocity of the wind is equal to 20 kilometers per hour, but they say it's moving from the north, meaning that it's moving from the north. If you are moving from the north, you are going towards the south, right? So the velocity of this guy is towards the south, and the south is this guy, right? The south is this guy. what will be the bearing for the wind then if it is here? So it's going to move from here to here, right? The bearing is the whole distance. So it's going to be like 180 degrees. 180 degrees is going to be the bearing. For this one, the bearing for this particular first body, the VC, right? The bearing is going to be 0.45 degrees because you have to measure from the north until you meet the body itself. When you come to the south, right? This is our body. This is our body on the south. It's on the south. It's falling exactly on it. So you have to move from the north straight to that. So this is 90. This is fully 90. You should have traveled 90 and another 90 to meet the VW, right? Then that will be the bearing for it. And if you for the body VC, right? VC will just move from the north to here. You have to travel 45 degrees before you meet it. So this becomes the bearing. And bearing are formed in 3 degrees. That's why I wrote 0.45 degrees. And this one is 180 degrees. Those are the bearing form. So at the end of the day, these things are represented in magnitude and bearing form like this, right? The units are the same, so you don't have to worry about unit conversion. Now, so the units are the same. So imagine the bearing form. I can write this in one like this. This is 0.45 degrees, and then comma this is 180 degrees. Now we got these two. Now we got these two. Now we are ready. We need to convert them to vectors. For vectors, it's going to be VC, right? You see how I'm putting the arrows there. I'm converting them to vectors, right? Vectors is going to be magnitude. That's going to be 80 sine bearing 45 degrees, and then this one is going to be 80 cos 45 degrees. Remember, we are just converting them first. VW is equal to magnitude is 20, right? 20 sine 180 degrees, and then 20 cos 180 degrees. So this is how to convert them to their bearing form, right? They are vector form. We convert them to the vector form using the magnitude and direction. So they are all converted now. But then, what are they asking now? Find the speed and direction of the car relative to the wind. So V of the car relative to the wind. We are finding VCW. So you're going to be VCW, you're going to be VC minus VW, right? This is what we have to do. So let's get to the next page. But at first, let me find these values. VC, right, is going to be equal to the top 80 sine 45 degrees. For that particular one, I think we need to find use calculator. 80 sine 45 degrees. I think if you have it in use the calculator to find this, you should make sure that um you stop at 4 decimal place. You can go more than that, but like at least 4, so that you don't lose the precision of the answers at the end of the day. So sine 45, right? 80 sine 45. What I have here is 40 root 2, which is the same as 56.5685. Then the bottom one, now I'm using cos, right? I have to use cos. 80 cos. So I'm still having 56.5685. Yeah, it's not like, yeah, you just put it in the calculator so that you don't do. Now let me do VW. VW vector from 20 sine 80, right? That will give you 0. 20 cos 180 is minus 20. That's what you get. Just put it in the calculator, then you'll be able to see what I mean, to just confirm what we have. Now let's go to the next page and then continue solving. Keep these values in mind. Then let's go. But now we are now finding VCW, which is equal to, which all vector form now. VC minus VW, right? Then we got our VC to be 56.5685. 5685, and the bottom one to just ended up being the same thing. Doesn't mean it happens all the time. Put it in the calculator. Minus the other one, we got 0 and negative 20, right? Okay. Now, the VCW will now be equal to, you put all of them together, right? We have 56.5685 minus 0 for this one. And then the bottom, we have 56.5685 minus 20. Minus 20, that will give you this particular thing. So at the top, we have 56.5685, and then for the bottom, right, we have 76.5685. This is what we got for these guys. But then let's try to represent this. Let's try to represent this in a cardinal point. In yeah, cardinal points, right? Or maybe on the graph XY axis. So I'm going to try to represent this on the XY axis, right? You see, don't try to write the value. Don't write the value. Just give an idea or which quadrant. Make sure you put it in the right quadrant, right? At the end of the day. Okay, this one, this is X and this is Y values. The S is positive. So S is positive. So we should be here, right? We should be here. And then the Y is also positive. So meaning we are limited to this quadrant, right? Y is positive here, S is positive here. So they all meet here. So our VCW will be somewhere here. VCW will be somewhere here. Are we okay? So VCW somewhere. We don't put the value, but then the signs on them tell us which quadrant they belong to. So they basically belong to this one. But then we need to find the magnitude of that, the value, the magnitude of that. For the magnitude of VCW, right? It's just like Pythagoras. What you do is that you square this side. So the X value is somewhere here and the Y value is somewhere here. So at the end of the day, it's like Y and X. They form Pythagoras right angle triangle. So use Pythagoras method to actually find the values. So now you have to find the square root of this plus square root of this. So square root of the x value squared plus the y value squared from what we have here, right? Let me put that in the calculator. So I have square root of 56.5685 squared plus 76.5685. So I have VCW will be equal to the magnitude to be equal to 57.24. Yes, 24 degree, 24. What of the unit? Kilometers per hour, right? So it's in kilometers per hour. So this was the, but now we need to find the direction now. That's the magnitude. But now let's find the direction. The direction, right, is going to be tan theta will be equal to opposite over adjacent, right? The y over x, so y value over x value. So theta will be equal to tan inverse of y over x. So let me put that in, theta will be equal to what then? So I'm going to find tan inverse of my y is 76.5685 divided by 56.5685. Then I got 53.54 degrees. Okay, so this is the angle. Then that angle, where do we put it? You have to put it between, always put it between the vector and the x-axis. If it were here, when you find the theta, you have to put it between the vector and the x-axis. If it is here, make sure you put the theta between the x and the, always between the vector and the x-axis. If it is here, it's going to be here because it has to be between the vector itself, the resultant vector itself, and then the x-axis. In this case, since we are here already, the theta is going to be here. Theta. So how do we say this? Right, this one is like east, this one is like north, right? And this angle is going to be like east 53.54 degrees north, right? Uh-huh. So this will finally be the answer that we got. Let me, I hope you have, I can clean this side. I can clean this side for you to make sure that you have a clean board. Now, let me just quickly represent the final answer. When we did this, the final answer is now VCW will be equal, has a magnitude of 57.24 kilometers per hour. Don't forget the unit. And at a direction of what? East 53.54 degrees north. Yeah, this is the answer for this particular question. This is the relative velocity now. Don't worry, let's solve another question to solidify the concept. We have this question for you to try, and then I want you to use the principle that we learned, right? In the next session, we'll quickly go through this particular question to solidify the concepts, right? Try this particular question. Let's see how it goes. So that in the next session, we'll see how the answer. Let me read the question for you. A car A, is moving at 30 degrees north of east. North of east, take care of the, remember the north of east. When they say north of east, we have explained this in previous session when we were learning vectors, right? Here we are now applying them. So these things, take note of them. With a speed of 60 kilometers per hour. Another car B, is moving at 50 degrees east of south again, with a speed of 40 kilometers per hour. Find the velocity of car B relative to car. Find the velocity of car B relative to car A. So we are finding VBA. The simple thing, we know that it's going to be VB minus VA. Then convert all this into their vector form. Then you manipulate and just get the answer. We'll solve this in the next session. See you there.